Hi, today we're going to be talking about our Python image filter processing project.
Our primary goal of this project is to create a Python program which can accept an image as an input from a user's computer and apply a selected range of filters to it to modify the image. And we will save the modified image to the user's hard disk. Our project comprises of 4 main features. The first one is the image loading from the user. The second is applying the filter and modifying the pixel data. The third one is to save the modified image to a hard disk. And the fourth feature is it's a practical introduction to image processing. Next is the image processing workflow. The very first step of this Python program is accepting an input, which is an image from the user. The second one is when the user keys a specific letter, it corresponds to a filter which will be applied to the image. And the third part is to save the modified image to the hard disk.
Next, for technical foundation and library selection, the primary library we used was Pillow, an actively maintained fork of the Python imaging library. It is a beginner-friendly interface. It supports various image formats. It is a comprehensive feature set, and since it is a widely used library, it has active maintenance and community. For key functions, the load image function loads an image from the specific file path into an image object. The filter function applies specific filters to the images, such as blur, grayscale, and sharpening. And the save image stores the processed image to disk in a specific path. For core programming concepts and implementation, this project implements a command line interface to load image, apply filters, and save processed images using the Pillow library, such as conditional statement, which we included nested if-else loop, for loop such as while loop, dictionaries to link each function to the image, and lastly lists and tuples to store and process each data.
Okay, so here's a quick rundown of our image filtering program. Now more onto the minor functions. As you can see, we got 5 image filter, 2 image manipulator, 1 enhancer. These 2 are completely unique from the others. We'll get on to them later on. And this is some sort of a info demonstrator, I suppose. Now, these filters often follow the same or similar coding structure. First, we print out that this string notifying the user that the system is applying this specific filter onto the image, and return that image with the applied filter. Simple as that. Here's a sharpening one, applying contour, and emboss. Now for grayscale, it's a bit different. We basically convert using convert L, which is a Pillow command. This thing just calculates the pixel of the image and turn them into just shades of grays. That's it. Now on to the image manipulator. We use a bit more complex coding structure. As you can see, we use try and except in order to handle errors, so that the program won't just crash if we put the wrong input into it. Now for the first function, basically it just rotates the image to whatever degree the user enter into it. Now onto the next one, flip RR, or flip left to right. It basically does what its name says. That's it. And to the brightness adjustment function, the user also enter the brightness that they want from a scale to 0, which is pitch black, to 2.0, which is very bright. If the user input something like a letter instead of a number, the program would just return this instead, invalid input, and return to default setting, which set just return the normal value. That's it. Now for this function, it basically works as just showing the top left, the pixel of the top left corner of the picture. That's it. The use of this is that it can serve as an alternative to check if the image is downloaded properly or not. For example, if the pixel on the top left of this picture is supposed to be red, but when you use this function on it and it just shows 0, 0, 0, which means black, then there's something wrong about it. Now moving on to the two most important functions in this whole system. All this thing does is basically load the image up onto the system so that the program can do its manipulation on it. Now, what we need to input is the file string. I meant the path string. Sorry. Now, in normal cases, the path string is the whole address of that file. But if it's just the if it's the case that our file is on the same folder or the same address as the system, we can just input the file name, and the program will run just like this. What it does is basically save the image onto the same folder as the original file. That's it. As you can see, these two has try and except to handle errors. This thing in specific case just illustrate or return file not found, and for other cases, unknown cases, it just set error and that case and state that case. Same here. Now moving on to the main function. This is the basically this thing tells the script to look in this specific space or path or folder, I guess, which won't make things more complicated later on if you just save the image onto the same file or folder as this script. Here is the menu for the user. First, we set the current image as none, so this variable will be able to later on hold whatever we are editing right now. We will load that thing up. This thing stores the original image path in order to allow reset. Now here's basically how does the whole program work. First, we store our function into a dict so that it is easier for our user to call and use them. And we use a while loop to receive the input. Okay, so here's a real demonstration. As you can see, when I click run, the program shows the path to the script of this file, lists out the command list, which is basically the menu. Well, first we got to load up the image, which is stated here that press L is what you do. So here, L. Well, what I'm going to edit here is this file called bird.jpg. So what I do is I just write that bird.jpg. That's it. Now we have just uploaded the file onto this system. Now we can do basic manipulation, like one, which is here you go. Now if you just continue to apply another filter, it will continue to edit from the product of the last filter you used, which they will overlap each other, which is not a very pleasant result. So before applying another filter, we have to reset the image. So we press R. Then here we go. The original picture is what system gave us now. If we press 2, I'll just give you a quick run through to each function and what does it do. So basically it's just that. It's sharpening, I guess. 4. Yeah. And 5. Now more onto the image transformation. Here we got rotation. We can just enter our degree, 90 degree. Reset again. Reset. 7. Just flipping the image. Simple as that. And 8 is the brightness adjustment. If we say 0.1. Oh. Yeah, as you can see, I mistakenly put in a dash So the program returns this instead. Let's try again. 0.1. Here we go, nearly pitch black. If we reset, yep, that's it. You can also make it very bright. Bright. Okay, let's reset the image. Show pixel. Yeah, that's it. A hitch. Well, basically this thing just stored the command that we have used on our image and list it out here. Each command is stored in the list and is printed out on this line, joining by this arrow and printed out. That's it. Yeah, you can save the image too. This time 8. Adjust brightness. I want it to be nearly pitch black. Yep. And now I can save the image. Enter the new file name, blackbird.jpg. Now the image is saved onto that folder. And when we're done using the program, just press Q and the program completely stops running. Now when we open this thing, here.
Now that you've seen the demonstration of our code, it's time to assess the difficulty and whether or not it meets your criteria. We rate our project difficulty to be 5 out of 5 because it is engaging and it has fundamental computer vision concepts at the pixel level. It is challenging to us because it requires understanding of pixel level data manipulation not only in the coding process but also when we're writing the project report. It introduces core computer vision concepts like image filtering and processing. It also bridges high-level image operations with low-level pixel processing, which is very detailed and precise. In terms of computer vision foundation that I've mentioned earlier, we've talked about things like pixel processing, image filtering, and also we implemented multiple algorithms. We also use various data structures that we've learned in class to store image data and turn them into manipulable structures. Now, in terms of the completeness evaluation, we have more than 100 lines of code. We have in total 12 functions. We've employed if-else, loops, data structures, dictionaries, lists, and tuples, and functions as core programming concepts within our code. We have followed the best practices, such as we have specialized functions for loading, filtering, and saving. We have command line interface with user-friendly menu options. We have filter options, which includes grayscale, blur, sharpen, and emboss. In terms of function implementation, we also look at modular design with dedicated functions from image loading, filtering, and saving. We have command line interface with clear user options, and also we've adhered to best practices in terms of following clear descriptive function names like load image, applied blur, and etc. Our main loop also has an intuitive user workflow that people can easily follow through with. In terms of project impact and conclusion, I would like to first talk about the project achievements. We've successfully implemented our Python program that loads, filters, and saves images in specified project objectives. We have a practical application of our program that demonstrates pixel data manipulation techniques and image processing fundamentals. In terms of code quality, we have implemented best practices including proper functions, clear structures, and appropriate comments. Now let's talk about the future. There are impacts and applications that we can possibly do. This code can be added on to process image, and also it is a solid foundation for computer vision. We've also demonstrated our clear programming skills, and also this gave us a lot of educational value.
Before we end this presentation, I'd like to declare our use of artificial intelligence in this project. Firstly, we used Gemini to teach us how to use the Pillow library, its functions and also its capabilities. And it also taught us how to implement the Pillow library into our codes. However, the actual programming was done by our group members. And the second AI that was used in this project is the Skywork, which we use for visual generation for the slides for further aesthetic. And lastly, I'd like to summarize our presentation. So firstly, we presented a project objectives and also the fully working code demonstration. We also presented within the 5 to 15 minute range. We declared our AI tools and usage. We used the Pillow library, which we programmed at least 100 lines of codes, 5 functions containing if, else, loop, list, tuple, set, dict, and string. We also fully completed our project, and it's a functional code. And we also implemented the project to its maximum difficulty, which is assessed in the previous slides. And our code quality, I can assure you, it is has high quality and appropriate and accurate. So thank you.